Hello, everybody. My name is Stevan Little, and I'm here to give a talk at the Perl conference here in Salt Lake on 18F. If you don't know what that is, you can ask me afterwards. And this is a talk about a module that I wrote, actually it's been a couple of years now, called Universal Object. So we'll go through here. So first question is, what is Universal Object? And it is basically a useful base class, and pretty much not much else. It is 125 lines of Perl that is including comments and spaces and all sorts of other stuff. So you could actually read the entire source probably quicker than I will explain it to you. It's Perl 5.6 compatible. Nobody cares about that, but it's kind of neat. If you're using 5.6 still, you may care about it, but most people aren't using 5.6, so they don't. To be a little serious, what is this? So what Universal Object attempts to provide is a instance construction protocol, meaning a way in which you can construct your instances and a number of extension points within that, and it follows a very strict order. Well, actually, I'll just show it to you. So first, new, obviously. So it provides a new. That's something that Perl doesn't have straight out of the box. When I wrote Moose many years ago, that was the key thing, being able to just say new without having to write it yourself. New we'll call build args. This is also something pulled from Perl 6 originally, but we had the feature in Moose, and now we're adding it here. There's a bless method. This is also stolen from Perl 6. It doesn't have too much usefulness, but it serves as sort of an indirection point. Then there's create. This is the part that creates your instance. That itself called slots and calls repr. Then there's build all and build, which is something from Moose. Don't worry if this doesn't make sense yet. That's what the rest of the talk is about, to explain those things. In addition, we have an instance destruction protocol, so a controlled way of destroying your object. And that's very simple. We use the built-in destroy hook, but that calls a demolish all, which then calls demolish. This is something, again, stolen from Perl 6 originally, ported into Moose. It doesn't really work any differently in this. So, next question, of course, is why? Why would I do this? Moose seems to work just fine. Why go messing with something? So, this actually started, I got involved in a project in about 2011 in an attempt to build a new object system for core Perl. It's not done yet. I'm still working on this. It has been an extremely long learning experience, humbling in a lot of ways and frustrating in a lot of ways. But this is a part that I basically felt was too useful to leave in that project, as it still sort of flounders and I'm trying to figure out what to do with it. So I decided it makes more sense to just cut it out and release it onto CPAN. And honestly, I kind of got sick of writing Moose and Moo and Mo style classes. Maybe I wrote the thing, so maybe I got sick of it at some point because of that, but oh crap, what happened? Uh-oh. Yes? Oh, okay.
It's the roadies.
Okay. All right, now where am I?
Sorry.
No, it's okay. Okay, I can talk through this part because it's really not that interesting. It's just bullet points on the slide. So I got kind of sick of writing classes in Moose and Mo or however those things go. I wanted something smaller. I wanted something lighter with less dependencies and just basically not nearly as much crap in it. So I'm going to have to advance some slides while he's doing that. And so the past about 5 years or so, I actually have not been writing any Moose classes or anything like that, and I've been going back to old school vanilla Perl object orientation, specifically because I wanted to sort of feel the old pain, if you will, and look for ways that I could essentially build universal object. Are we almost there yet? Because now we're on the code. All right, we got to wait for this to come back up because I got code. Why is that doing that? Do I need to do a different?
You should be good.
Okay, I just lost my browser window, so. Ah, there we go. What the heck is it? There we go. Okay. So, let me try and get my head back in the game here. Moose provided a feature called attributes. And I think, in my opinion, that was one of the key features that Moose provided. And basically what attributes allowed you to do is easily declare what were the slots or members or fields or whatever you want to call it of your class. I'm going to use the word slots after this from now on. So it allowed you to define that. That's something that plain Perl doesn't do, and you basically have to build that all yourself. And along with it, it would generate all these other accessor methods. I feel like this ended up creating sort of people wrote, they gave public access to their slots. And that kind of discourages good encapsulation. This was a very early criticism of Moose by somebody on Perl Monks, and it's stuck with me for like the last 12 years. And so this was something that I specifically wanted to do when I approached this. Because vanilla OO Perl doesn't know anything about your slots, and it doesn't care. And that actually tends to lead to better encapsulation. But it does require a lot more work. And so universal object is an attempt to try and meet in the middle here. So now we're going to do some code. I said I'd go through all those points. So new takes, obviously the class is the first argument, and then whatever you pass into it, and it's going to return your blessed instance, obviously. So with, those colors aren't so great. You can see here, this is as minimal as possible. So you need to set your own is a variable, and essentially what I've introduced in universal object is the idea of a has hash, a package level hash in which you define your slots. This, to me, feels like it matches quite nicely with the ISA. It does seem very old school and clunky. Yes, I understand that, but understand that this is the base level stuff. To reference Vicky's earlier talk, these are like base producers in the ecosystem. Like you probably don't use this directly. You probably use somebody's built system on top of this. So has is a way to specify your slots in a very, very simple way. So I think, does everybody looking at this, does it make sense? Is there anything that maybe looks a little confusing, everybody? It should be, I hope it's very, very simple. Each of the keys to the hash is the name of your slot, so it will become a hash key in your instance. And then the subroutines after that are essentially the initializers. So if you want, with age it starts at 0, so that'll be the default value. Name, we don't have a default value for that. So we actually call die in there. So when we attempt to get the default value, it will just explode. And so that's about how we can essentially implement required methods in here. And then of course you have to write your own accessors. That doesn't come with this package. And that's it. It's just how they work. And it's a key value pair that's the base, how the base new constructor works, very similar to Moose. If you want to inherit stuff, we're adding to ISA here with person, the previous class that we had. And then you'll notice in the has, we're basically bringing in the values from our superclass. The reason is that universal object knows nothing about your inheritance, or cares nothing about your inheritance relationship, is not going to resolve all this stuff for you. You have to resolve it for it. It will create an object based on all the keys that might be inside your has hash, and how they got there, it doesn't care. One of the very interesting things about this is you can actually introspect, even though we've copied all that hash into there, you can still figure out which slots don't belong to that class. And this gets into a bit of a Perl guts thing, but essentially Perl in its internals will make a note of what stash or what package your subroutine was compiled in. So all I have to do is look at those subroutines and I can see where they were compiled in, and I know that they're inherited. But that's a pain in the ass. Who wants to type all that stuff out? And to be honest, you probably should be doing a begin block around the ISA and the has and all this stuff like that. It gets very messy. I told you at the beginning I'm going to try and make it not so much work for you. So I have, and it's not actually included with universal object, it's a separate module, but I've created a slots pragma that does exactly what you think it would do, which is to populate that has variable. And you don't have to handle inheritance. It will handle the inheritance for you. It will make sure to do everything at begin time, and it will do most of its work at begin time, but it ensures that by the time you reach the unit check phase, which is sort of the last phase before runtime, all your class will be completely set up. That's the slots pragma, but yeah, anyway. So that's your basic stuff. Like I said, there's not a lot to this. It's very, very straightforward. So, but where the power comes is the extension points. So build args is your first extension point. It works exactly like Moose does, and only slightly similar to Perl 6 because we can't imitate all of Perl 6. But essentially, build args is the first thing. It gets all your arguments that you passed into the constructor, and it's given a chance to turn that into a hash reference. And this hash reference is essentially just the canonical form of what you passed in. And it needs that as it goes through because it needs to be able to match this to the slots. So if you look at this class here, we have it's a point class with an x and a y, and we want to allow basically what this is basically saying. If you've only passed me 2 arguments, then I'm guessing that they're the x and the y, and you're not passing in the keys. So I construct that for it and return it. If that is not what you passed in, then I just call the super on that and let it do its own thing, which will just essentially process the args in a normal way. Yes, I understand that the scalar args equals 2 is probably not the best way to do that, because if you passed in a single hash key, yeah, anyway. So bugs in my own slides. But anyway, build args is the first step. So it allows you to customize the interface to your constructor. So if key value pairs don't make sense to you, you have build args to do literally whatever you want. It's also a good place to do a little bit of validation, not too much, but a little bit of validation, and sometimes even a little bit of type checking, because it's before all the other work starts to happen. The next step is bless. Bless is, like I said, almost completely useless. It just serves as an indirection point, so there's no example with that. Create is the indirection point that it sort of enables, and create is where you're given the result of the arguments that were passed into the constructor, and it will do a bunch of things and return an instance. It actually returns an unblessed instance, and bless will do the blessing of it, but details. Where create comes in very handy is that it allows you to very easily use different representation types. So here's a simple example of the point class with x and a y, and we're going to store it in an array because arrays are faster and smaller and cheaper. So essentially what this does is it calls the slots method, which we'll explain in a little bit, to get back all those definitions of the slots. And then either it pulls it out of the prototype, so either pass it through the prototype, or it's going to call the initializer. It's a bit of a very dense Perl, but my slides, you can't fit too much code in slides. And actually, it's the wrong way to do it anyway. You'd really want to do it like this. So I'm going to walk over to the screen and sort of explain this because my pointer is not working. So repr is saying it's an array ref. So that's just being a little pedantic. It's not really necessary. Then we call slots, and we get the repr, which is going to be an array ref. And then essentially we sort the keys here because you want it to be a predictable setup. And then we do the same thing as we did before, and we assign it to the array, and everything works. It works well in inheritance relationships as well, because slots will always return all the slots that are necessary for that. So when you sort them, you'll always have all the keys. It works in multiple inheritance, et cetera, et cetera, et cetera, et cetera. Repr, which we saw before, is also a possible extension point. Here, it just returns basically a bare reference. But repr comes in very, very handy if you need to extend a class that doesn't use universal object. So essentially, if you think about this for a second, the representation type of the class, if you own the class, you can define it however you want. If you don't own the class and you're subclassing it, you're stuck with whatever they got. So essentially, their instance is your representation type, and then you just sort of do other things to it, whether they're good or not is an entirely different story. So what this does is this is just a Sax handler. Anybody XML, fans of XML here? Yeah. XSLT, I love XSLT. One person, cool. So this is a simple Sax handler. It inherits from a universal object, and then it inherits from the XML Sax base. And then the repr does the dirty work of creating initializing the parent class, and then universal object will take over and make sure that that stack that we're storing there in the slot gets put in the right place. and is then usable. So it's very easy to extend your non-universal object classes with universal object. 5 minutes? Okay, good. So slots. I talked about slots. For any of you that were disgusted by the whole, I'm going to store these things in a package variable, you don't have to do it if you don't want. Because slots is where we call and get the whatever's in that package variable, you can just make it a method and have it return whatever you want. So here's an example of not even using the built-in package variable and just doing it by, well, I don't know how you call this, not by hand, but anyway, defining the slots yourself. And of course it works quite cleanly for inheritance, naturally, because you just call slots in there. So this is a silly example because it's just hard-coded, but you could be pulling these things out of a database, pulling these things off of disk from a YAML file or a Mongo or whatever, and you could be pulling these definitions in from outside if you want. That'd be maybe a little dangerous, but whatever, it's Perl, right? So, yeah, it's already dangerous, exactly. So slots, again, serves as a way that you can begin to customize this. So one of the goals of Universal Object was to hopefully get all the other people who build object systems to just use this as their base class. And then we have a base, sort of a substrate that we can all cooperate on, and then you can put your opinions on top of that. And slots was necessary to basically allow people to get at stuff that's not in the normal place that they would think it'd be. So I'm going to go through the last couple of stuff here because I know I don't have too much time, so I'm going to be a little quick here. One of the other things, I was doing a bunch of Scala stuff, and I'm a big fan of functional programming, Haskell, OCaml, things like that. And of course, those all talk a lot about immutability, and of course, the new hot topic of concurrency and such like that. Immutability is part of that because, yeah, you don't have to worry about state changes between threads and blah, 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 blah. So we don't have threads, so that doesn't really matter, but immutability is kind of nice. The ability for people to not change your class, or for, if they attempt to change class, it breaks. So I added immutability to Universal Object because it just sort of worked. And essentially what it does is it just figures out what type of instance you have, and then it locks it in some way. So it just uses like internals to make it read-only. This is an example of wrapping like a subroutine. So that subroutine is owned by Perl. So we really shouldn't be altering it or screwing with it too much. In fact, if we bless it, then the actual code ref gets blessed. So in this case, we actually want to just bless a reference here. And that's it. No one will ever change this class. We know that no one will ever change this class because it's immutable, and they can't do that. So this is actually, this is maybe an additional 40 lines to that 125 lines there. So it's also very, very, very slim. I find this helps me as I design a set of classes, thinking about what is immutable and what is, or what could be immutable and what needs to be altered. It's just a good exercise as you're building these classes and then enforcing it upon yourself. So last thing, custom slot objects. This one gets a little messy. I left it to the end because I was hoping I could skip it, but I think I have a minute, so I'll do it. Before you're just putting subroutines, right? You're just putting subs into the other side of the slot. Well, that doesn't do very much. It's not very intelligent. So you actually can store whatever you want in there as long as it can turn into a code ref. So here's a custom slot object that allows you to pass in a default value, and then it'll do all the stuff. And you can see in the next slide that. So you put it in there because as far as anything else is concerned, the first time it cares about anything is when it's going to try and call it as a code ref. So Perl's overloading will just take care of that. So we can just store it in there. But that also has the added benefit of it's there still. That hasn't been turned into a code ref. That's the original object. So you can then begin to get into introspection type stuff. And you can essentially look at those things, or look at the using mop, which is the talk that I have about tomorrow. You can get into those you get into those spots and you can check out those objects. And I'm out of time, which is good because questions in the end. But sorry. Anyway, you can always ask questions out in the hallway, but I think we got to sign off here. So, okay.